All right, guys, so where we left off before fall break was talking about quadratics. We talked a little bit about solving quadratics, factoring special quadratics are difference of perfect squares. We're talking a lot about quadratics, and what we're going to be talking about today is solving. Now, we've covered one method for solving quadratics, which was factoring and using the zero product property, which told us that if we multiply two things together and they equal zero, one of them has to be zero. And really, that's the method we use to solve by factoring. Now, there's two other methods that we can solve quadratics: by graphing and using the square root method. Now, when we graph, we want to find the x-intercepts, the values of x that will make the y value be 0. Because when it crosses the x-axis, the y value is 0. So we're finding the x-intercepts, we're finding these solutions. So when we solve by graphing, the first thing we need to do is get it equal to 0 or y by itself. In most cases, when we're solving, we need to get the equation equal to 0. Because if we can get the equation equal to 0, we can plug it into the graphing calculator and see where it crosses the x-axis. So this first one here is already set up as x squared minus x minus 6 equals 0. So we're good on getting it equal to 0. So we can go on and grab the graphing calculator and let it graph it for us. So the first thing we'll need to do is turn it on. And once we get it turned on, we're going to hit y equals up in the top left corner, y equals. Now, there might be some equations typed in already, and if there are any, we can go on and hit clear and clear them out. We don't want anything typed in any of these lines here. We're able to get to this screen here. All right. Now, the first thing we're going to do is type this equation in. So we have x squared minus x minus 6. Now, our x, there's different ways to get to it, but the easiest one is to hit the button next to alpha. Will get us x. Then we hit our square button, minus x minus 6. Now, we don't want to use the negative button in between x squared and x and 6 because it's not actually negative, it is minus for subtracting. The only time we'll use the negative is if it's in front of the first term. Are we able to get this typed in? Yes? All right. Now, after we get it all typed in, we're going to hit graph up in the top right. And when we hit graph, it'll graph the equation for us. Did we get something like this here? Yeah. And again, when we graph, we're looking for the x-intercepts. We're looking for the values of x. That's going to make the y value be 0. And we see that it crosses the x-axis, one on the right or left side and one on the right side. So we have one negative value and one positive value. Now we can count the little hash marks to get there. The other thing we could do is we can go second graph, second graph. And it gives us a table. It gives us a table of the values given a given x value. If we plug an x value in, its corresponding y value. And again, we're looking for the values of x that make the y value be what? 0. And one of the values of x that makes y be 0 is negative 2, because when x is negative 2, the y value is 0. What's another value? Another value would be 3, because when x is 3, the y value is 0. Now, a lot of times, students will say 0, negative 6, but again, we're wanting to know what value of x makes y be 0, not what value of y is making x be 0. So here the two solutions are -2 and 3. And that's it. Now, if I wanted to check, we don't have to, but we could check. I can plug -2 in for x and see, does this equal 0? Well, -2 squared, -2 times -2 is +4. Our negative 2 is going to become +2 minus 6. Our 2 plus 4 is 6, and 6 minus 6 is indeed 0. So that works. We can do the same for 3. 3 squared minus 3 minus 6. Now 3 squared is 9. Our -3 would be -3 minus 6. 9 minus 3 is 6, and 6 minus 6 is indeed 0. Questions on how we solved the first one by graphing? We're ready to do the next one. So our next one is -2x squared minus 2 is equal to 4x. So what's the first thing we need to do? We need to second quit. So the first thing we need to do is get this equation equal to 0. So we're going to have to subtract 4x from both sides. Because on the right-hand side, 4x minus 4x would indeed be 0. Now, -2x squared, -4x, and -2 are not like terms. X squared, x had no variable, so we're just going to put them in standard form. So we have -2x squared minus 4x minus 2. Because the first thing we need to do is get this equal to 0. And once we get it equal to 0, we can hit y equals. We can hit y equals. And we can clear that out. Now it is -2x squared. So this time we'll use the negative 2x squared minus 4x minus 2. So we type the whole thing in. Now this is nicer than trying to do this by hand, because if we did this by hand, we would first have to find the vertex and then find one point to either side and work our way out until we found values of x that make the function be 0. Now it turns out here the vertex is a 0 at x-intercept. And we can see here, it looks like the x value is -1. If we want to make sure we can go second table. And as we see here, when x is -1, the y value is 0. So our solution for this here, it's telling us that x is equal to -1. Now, we will talk about this again later, and we'll go into more in depth later, but when we look at graphs of polynomial equations, not polynomial-like, but polynomial equations, these higher degree polynomial functions, when the graph touches the x-axis but does not cross it, the solutions at that point of intersection are considered to have an even degree. What that means is that the number of zeros at that spot is an even amount. So we actually have two solutions at -1. It tells us that x is equal to -1 and x is equal to -1. It shows up twice. So we'll get more into that, especially once we start talking about higher degree polynomial functions. But x equals -1 is the solution we would get to by graphing. Questions on this here? So this next one here, we have x squared minus x plus 12. Is the equation equal to 0? Yes. Since the equation is equal to 0, we can grab the graphing calculator and say y equals. We'll clear it out and we'll type in x squared minus. Do what? How do I go back to the table? Second graph. So that is the table.
How do I go back to the graph?
So graph. So to type it back in, we got to go y equals. Go and type it in, x squared minus 8x plus 12. And once you get it typed in, we're going to hit graph. And we get something like this here, yes? Now we do see that it crosses the x-axis in two places. And both of those values are most likely going to be what? Positive, yes? So it tells us that when we look at the table, we go second graph, that my two solutions are going to be positive. And the two values we find are 2 and 6. Most likely you're going to have to scroll down quite a ways to get there. So for us here, it's telling us that x is equal to 2 and x is equal to 6. And if we wanted to check it, all we have to do is plug it back in. We have 2 squared minus 8 times 2 plus 12 is 0. And 6 squared minus 8 times 6 plus 12 is also 0. So it tells us 2 and 6 are solutions to this here. They are values of x that would make this function be 0. They are our x-intercepts. That's exactly what we're looking for. Questions on this here? Be ready for the next one. So we have 1/3 x squared equals 6x minus 20. For this here, we need to get the equation equal to 0. Now to get this equation equal to 0, what's the first thing we can do? Well, we can subtract negative 1/2, or we can subtract 1/2 squared, 1/2 x squared from both sides. Because our 1/2 x squared minus 1/2 x squared is 0. And again, like before, we don't have any like terms. If we did have like terms, we would combine them and group them together. Now what that tells us is that 0 is equal to negative 1/2 x squared plus 6x minus 20. Now if we were solving this by factoring or doing other methods, we would want to simplify that 1/2. We try to get it to be a whole number or an integer and get rid of that negative or make a be positive. Now the nice thing with graphing is the graphing calculator does not care if a is positive or negative. If a is a rational number or an integer. So the first thing we're going to do is hit y equals. We'll pull this back up and clear it out. Now the first number we're typing in is that negative 1/2. Alpha y equals enter. Alpha y equals enter will give us a fraction. Do the ones that aren't crossed out. Don't have to do all of them, but at least 1 or 2 of each. And we'll, yeah. Did everybody get the fraction? So alpha y equals, enter. And once we get that, we can type in our negative 1/2 x squared plus 6x minus 20. So alpha y equals enter lets us type it in as a fraction. And once you get it typed in, go on and hit graph. So we hit graph, and we get something like this here, yes? Hit y equals negative 1/2 x squared, and then it was plus 6x, because the 6x was positive, minus 20. So where does it cross the x-axis? Does it cross the x-axis? No. And because it does not cross the x-axis, it tells us that there are no real solutions. There are no real solutions. There are no real values of x that will make this function be 0. Now, it does not mean that there's no solution. There's no value that will make this function be 0. It's just the values of x that will make it be 0 are not real numbers. And we'll talk about those later. But there are solutions. It's just not real solutions. And it feels like it might be dealing something with maybe the fact that we have the negative 2x, and it's not. It's just how the values of this function work. Because if I wanted to, I could multiply this whole thing by 2. And 0 times 2 is 0. 2 times negative 1/2 is going to be negative 1. 2 times 6x is going to give us 12x. And 2 times negative 20 is going to be negative 40. Same equation, negative x squared plus 12x minus 40. Still, it does not cross the x-axis. So again, this has no real solutions. So graphing works well if it crosses the x-axis, because if it doesn't cross the x-axis, we're going to have to find a different way to solve these. We're going to have a different method. Graphing does not solve every type of quadratic that we could have. So if we look at the next one, 4x squared minus 12x plus 9 equals 0, we want to find the values of x that will make this be 0. So if we graph this here, again, it is already equal to 0, so we can say y equals 4x squared minus 12x plus 9. So we can type the whole thing in and hit enter. We got it? So this one does cross the x-axis, yes? Well, yeah, it looks like it crosses it right there, and it's between 1 and 2. But if we notice here on the table, it doesn't give us a value. We just know it's somewhere between 1 and 2. So there are methods for using the graphing calculator to approximate to try to find this value. But as we can see here, a lot of the rational numbers, it may not be as nice to try to find them, because the calculator is able to approximate and get close or tell us what the exact value is if it's a nice value, but it doesn't always give us the value that we want. So sometimes it might be nicer to factor it, because if it does cross the x-axis, there is a good chance that it will factor. And if we solve it by factoring like we did last week, or the week before, the first thing we would do is get the equation equal to 0, which it is. Then we'd factor out the greatest common factor. Now, since there is no greatest common factor between 4, 12, and 9, we go to our two sets of parentheses with 3 spaces. Then we find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term sign is negative, the signs are opposite. But since the third term is positive, it tells us the signs are the same and match the sign of the middle term, so we'd have negative and negative. Factors of the first term, we're looking at the factors of 4x squared. So x squared is going to be x and x. Our factors of 4 are 1 and 4 or 2 and 2. I'm going to pick 2 and 2. Now the factors of the third term, factors of 9 are 1 and 9 or 3 and 3. I'm going to try 3 and 3 first. And we can check and see and make sure we get the correct middle term. 2x times negative 3, 2 times negative 3 would be negative 6x. Negative 3 times 2x would also be negative 6x. And negative 6x minus 6x, negative 6 minus 6 would indeed be negative 12x, which is the middle term we wanted. Now, because we do have two things multiplied together to equal 0, one of those has to be 0. So either 2x minus 3 is 0, or 2x minus 3 is 0. At this point, we can solve. So for the one on the left, first thing we can do to solve for x is to add 3 to both sides. Because our negative 3 plus 3 would be 0. And 0 plus 3 is 3. Then we would divide both sides by 2, telling us x is 3 halves. Now we can do the exact same thing to our other 2x minus 3. We can add 3 to both sides. Then divide both sides by 2, telling us x is 3 halves. So we find that x is 3 halves and x is 3 halves, which really emphasizes the fact that the graph intersects the x-axis at the point 3 halves, comma 0, and it doesn't cross it because we have that value twice. Now, there are different methods for us to be able to calculate 0 and values using the graphing calculator. And for the most part, if it's a nice value, 3 halves, 1.75, for the most part, it'll give it to us. But if it gives us, or the answer is the square root of 3, we would have to know the decimal approximation of the square root of 3 to know for sure that was the correct answer. So again, graphing is nice if we do have integer answers, possibly rational answers, but it's not going to work for every single answer, every single quadratic. You're good? So that brings us to our next type of method we can use for solving, and that's the square root method. Now, the square root method has 3 main steps. Now, the way that we know that we can use the square root method or the root method is if we do not have a variable to the first power. So for square root method, we need either x squared or the variable to be inside a set of parentheses being squared. The only place the variable can be is either as x squared or inside a set of parentheses being squared. So here, since we have 4x squared minus 31 equals 49, the only place we have x is with that x squared. We can use the square root method. And the first step is to get the squared term by itself. We need to get the squared term by itself. That's the first step. So here our squared term is x squared. However, we do have a few things with it. So the first thing we're going to want to move is the 31. Since it's being subtracted, we're going to add, because our negative 31 plus 31 is going to be 0, leaving us with 4x squared on the left-hand side. Now 41 plus, or 49 plus 31 is going to be 80. Now at this point here, the squared term is not by itself because we have 4 being multiplied with our x squared. So at this point here, we're going to divide both sides by 4, because 4x squared divided by 4 is just going to give us x squared. 80 divided by 4 is 20. Now at this point here, we do have the x squared term by itself. Now our next step, and this is why we call it the square root method, is we're going to take the square root of both sides and put a plus or minus next to our number. So when we look at this here, we need to take the square root of our x squared, and we need to take the square root of 20. We need to take the square root of both sides. Now the left-hand side's nice. The square root of x squared is going to be x, because when we take the square root, we're looking for what times itself gives us the term inside the radical. So when we look at square root of x squared, it'd be just x. On the right-hand side, we're looking at the square root of 20. We're looking for what times itself is 20. Unfortunately, there's not a nice integer answer for this here. So if we wanted to do this by hand, we'd have to break up 20 into product of primes, or we would look for perfect squares, numbers that times themselves. So 4 would be a perfect square factor of 5, because 4 is 2 times 2. And the square root of 4 would simplify. The square root of 5 would not, telling us it's 2 square root of 5. Now, whenever we take the square root of both sides, we do have to add the plus or minus, because a positive number times itself is still going to be positive. A negative times itself is still going to be positive. Now, the other way we could have done this is we could have taken the yellow calculator, our 30xs, and told it to simplify the square root of 20. Tells us it's 2 square roots of 5. The 30xs does a great job at simplifying radicals. And then we would solve for the variable if needed. This one here, x is already by itself, so we're done. We're saying that x is equal to plus or minus 2 square roots of 5. Questions on this here? Let's look at the next one. 3x squared minus 9 equals 0. So we can use the square root method because we do have an x squared term. We don't have a variable to the first power because we have x squared. If we had x, we could not use the square root method. Now we could try graphing this. 3x squared minus 9. Now we see it does intersect the x-axis at 2 spots, but it's not nice spots. It's not nice locations. So it might be useful to use the square root method. Now the first step in the square root method is to get the term being squared, or in this case x, by itself. We want to get it by itself first. So the first thing we can do is add 9 to both sides. Because when we add 9 to the left-hand side, it leaves us with 3x squared. Now our 0 plus 9 is 9. Now x is not by itself, so the next thing we need to do is divide both sides by 3. 3x squared divided by 3 is x squared. 9 divided by 3 is 3. Now we do have the squared term by itself. So we can move on to step 2, which is taking the square root of both sides. So the square root of x squared is going to be x is equal to, we have to include the plus or minus. Now we'll need to simplify the square root of 3. Now we can use a calculator and tell it, ask the 30xs, what's the square root of 3? Well, the square root of 3 is just the square root of 3. And that's it. Now if I wanted to check it, 3 times the square root of 3 squared minus 9. Well, the square root of 3 squared is actually just going to be 3. Because we would get the square root and square would simplify. Then we can do 3 times 3, which is 9. Minus 9 is 0, just like we wanted. If we did this with the negative square root of 3, well, our negative square root of 3 squared. Well, the negative times itself is going to be positive, and the square root of 3 times the square root of 3 is still 3. Then we'd have our 3 times 3. 3 times 3 is 9, and 9 minus 9 is indeed 0. Questions on this here? All right. Let's look at this one here. 2/5 times x plus 3 squared equals 5. Now, the only place where there's an x is inside that set of parentheses being squared, which is fine. Because if it said that 2/5 times x plus 3 squared equals 5x, we couldn't use the square root method immediately. We would have to rewrite it so that we just had the variable inside the parentheses. So if it had been like this here, we couldn't just use the square root method. Now, because the variable, the only place the variable shows up is inside this parentheses squared, we can use the square root method because the only place where the variable is inside the squared term. So again, our first step with this here is to get the squared term by itself. In this case, it's not x, it is x plus 3 squared. We need to just get that term by itself. Now at this point here, the only thing that is with that squared term is our 2/5. So the first thing we can do is divide both sides by 2/5. Because 2/5 divided by 2/5 will become 1. We'll simplify to 1, leaving us with x plus 3 squared is equal to 5 divided by 5 over 2/5. 5 divided by 2/5 is 25 over 2. 25 over 2 is the squared term by itself. Do we have anything being added to our squared term? Do we have anything being multiplied or divided by our squared term? No. We do have the plus 3 inside the parentheses, but that is a part of the squared term. It's not actually being applied to it. Our squared term is by itself. Now at this point here, we can take the square root of both sides. On the left-hand side, our square root and square will simplify out. They undo each other. They are inverses. Is equal to plus or minus. Now we need to figure out what the square root of 25/2 is. Now we can use the calculator to find it, but if we're going to use the calculator, especially the 30xs, we do need to split the radical apart. Because according to the properties of radicals, the square root of m divided by n is equal to the square root of m divided by the square root of n. Especially if we want this in simplest radical form. So we can type it in as the square root of 25 over the square root of 2. Which tells us that the square root of 25/2 is 5 square roots of 2 over 2. Questions on this here? Is x by itself? Well, no, up to this point, x has already been by itself, so we still have to solve. We still have to finish getting x by itself. So here, our next step would be to subtract 3 from both sides, because our 3 minus 3 would be 0, leaving x by itself. Now, if it is simplifiable, if we can combine these terms, we need to. Now, negative 3 and 5 square roots of 2 over 2 are not like terms. Negative 3 plus 5 square roots of 2 over 2 is this here. Now, these are equivalent expressions. They are the same thing, but we're just going to leave it in this form here because 5 square roots of 2 and 3 are not like terms. And normally we put the number that we're adding or subtracting to the plus or minus in front of the plus or minus. Because we're saying that we have negative 3 plus 5 square roots of 2 over 2 and negative 3 minus 5 square roots of 2 over 2. Questions on this here? We're going to stop there and we'll